CO2 powered flippers. Brilliant fun until the gas runs out. So I'm going to try and fix that problem this week on the Team Shock Builders Log. Hi everyone, welcome to episode 9 of the Team Shock Builders Log, and this time we're going to be doing something a little bit different. Now, I'm a big fan of pneumatic flippers, as I'm sure most of you know. I've had a go with them from all weight classes, ranging from the little tiny 150 gram ant weights through to beetle weights, and then of course through the featherweights and the 110 kilo heavyweights as well. So I really have had a go at a good wide range of pneumatic flipper robots. But they all have one common problem. What happens when your CO2 runs out? My love for pneumatic flipper robots started with the original run of Robot Wars back in the late 90s and the early 2000s. Seeing machines such as Chaos 2 and Cassius, built by the roboteering legends George Francis and Rex Garrett, really captured my imagination, and they got me wanting to build this type of robot. And in fact, our first ever robot we built as Team Shock was a machine called Airwave, all the way back in 2003, and that was built using the Rex's Robot Challenge instructions, which showed you how to build a basic flipper out of things like Coke bottles and bicycle pumps. Great way to get involved in pneumatics if you ever wanted to have a go. Since then, we evolved to the featherweight class first, building a low pressure flipper called Shockwave, not to be confused with our Robot Wars entry, and then we had the high pressure flipper Aftershock, also gave us the name for the heavyweight we used later on. And ever since then, we've continued building more and more. The Heatwave series of robots is currently up to number 5. We still have Mark 4 running, which is a low pressure flipper, and Mark 5, which is one of our most powerful high pressure systems. Then our recently built robots such as Soundwave, and then we also have Polaris and Slingshot, which joined us at the end of 2022. Now, all of these are very CO2 hungry robots. We have to fill up a canister, not unlike this one. So this is actually the one from Slingshot. Goes in the back of the robot and we fill it with liquid CO2. And that's great, we get a load of power out of these, but what happens when it runs out? Well, that's the problem that we're hopefully going to solve in today's video. Because what normally happens is at the end of the battle, we have to refill this bottle, which is great all the time you're at an event and you can get some CO2 for either free or as part of your entry fee. But when you're testing at home, you can get pretty much test with what you've brought back with you, which is normally one full tank. After that, you're a little bit stuffed. The way I've got around it in the past, I've managed to go and buy some out-of-date CO2 fire extinguishers, still full up, but out of date. And you can normally buy those on eBay for about 15 quid. But they don't last very long. They're a short-term solution and you can fill the bottle a couple of times. Not very good if you want to do a repeat set of battles or sustained testing if you're changing something on your robot. So I'm going to have a look at solving all of that with a new way of working. Let's take a little look at my idea. So for my little experiment, I'm going to be using this robot, which is Polaris. Now, Polaris is one of our newer machines. We bought it from Glenn of Demon Designs, and it is an incredibly powerful CO2 flipper. It's got a massive 20-ounce gas tank that fits at the back of the machine, and that feeds a fully custom pneumatic system which powers this arm, and this can flip with a huge amount of power. Here's my plan. I want to replace that CO2 bottle in the back with an air compressor. Now, this is the cheapest one I could buy off of Amazon. I've had a little bit of practice with these in the past, as I had a robot called Airwave a few years ago. Have a little look at how that got on. As you can see, Airwave was a very successful attempt at building a compressor-powered flipper, but that machine was designed to have it in there from the outset, so it was never designed to run off of CO2 first. The problem I've got is I'm trying to retrofit a CO2 robot with a compressor, and I don't want to start messing around taking out the existing pipework and also changing the wiring and the batteries and that side of things to accommodate a compressor. I want it to be its own isolated system that can fit in the place of the existing CO2 bottle with minimal changes to the robot. That means theoretically any of my machines which are running the same size tank could share this new compressor setup. And for me, that would be Polaris, Heatwave Mark IV, Heatwave Mark V, and also Aftershock could all share this same system. Let's see if we can make this work and break down some of the components that we're going to be using. Right then, my starting point is a 20-ounce paintball tank. This is a standard type you can buy, used most commonly in CO2 power paintball guns, and it is a bog standard cylinder. About 80mm diameter, the main part of the body is about 200mm long, and of course we've got the tap at the end. Now this is going to be crucial, as this is what connects into the rest of all of my pneumatic systems, because they've all got adapters that fit the threaded end of this bottle. So whatever I'm going to design has to have one of those, and it can't really be any bigger than what we see here. And remember, what I'm looking for is something completely self-contained. So I'm going to have to not only get the compressor, I'm going to have to get the end threaded part, and I'm going to have to fit any batteries and power source inside something the same sort of size as this. Now that's going to be quite tricky, because I've got this compressor, I mentioned it earlier. It is the cheapest one you can buy on Amazon at the moment. It's about 11 quid. Ordered it on Prime last night, it's here today. So it is a really nice starting point, and unlike with Airwave, I am starting with a brand new one right here that I'm going to take apart. So I think the next job is going to be strip this down, see if we can get it to even vaguely near the right sort of size, because if that doesn't work, then I'm going to have to really rethink this whole idea. Okay then, all the screws are out, so let's take a little look inside our compressor. And in here, it really is as basic as we get if we can take out the other side of the shell. So we have a little 12-volt motor here running on a single stage gear reduction to the crank, and there's the piston here. And then coming out of here, we have got the pressure gauge off of one side, and we have got the hose that would normally go to your car tyre on the other. What I'm going to need to do is take off this part here so I can remove the hose, and then I can fit one of my own pneumatic tubes onto the end there. So let's give that a little look now. Right then, there we go. That is the hose removed. That has left us with this little barbed connection here, which I can fit an 8mm pneumatic pipe to. So that's standard pneumatic pipe, and it glues on there really nicely. I've used that with Airwave before, so I know that is going to work. The unit is a little bit big if I compare it alongside the CO2 bottle, but not by a huge amount. I reckon if I take off the pressure gauge, I might be able to get a little space to play with, and yeah, I think it might just work. The other bit of the puzzle though is one that I'm quite pleased with. So the other big issue I had was connecting the whole compressor system into the same pneumatic port that I use on the rest of the featherweights. So to do that, I have got a valve, a tap off of a 12-ounce CO2 bottle, which uses the same thread that I have on my other machines, but I'm able to drill and tap the end of it to fit a 1/8 BSP fitting. And onto that, I've been able to screw in a standard 8mm push fitting that will connect straight to that pipe that I've just put onto the compressor. Now for the first test, I'm not going to run any kind of pressure limit or pressure switch. I'm going to be running this in Polaris. It can take up to full pressure CO2, so it will definitely take anything the compressor will throw at it. The next development after I've done the first trial of this will be to integrate some pressure sensing into the system to control when the compressor is on and off. And you can do that using a very basic 12-volt compressor pressure switch. But for now, as a proof of concept, I'm going to hook up this compressor to what I've got here, and let's see if I can get any pressure going into Polaris. So here we are with Polaris, all connected up. So we've got the adapter fitted there. We're just running down the pipe into the compressor, and I've wired that into a little power supply for the time being, so we can give it a little test. Let's see what we get. So I'm going to switch on the power supply. There we go, we can see pressure starting to climb, so it's 20 psi, 30. We'll let that build a little bit more, and then we'll give it a little test, see what we get. Now bear in mind, this normally runs on about 800 psi, So we're well under pressure here. We're currently up to about 50 psi. Let's see what we get. I think we'd safely say a nice bit of power there. I'm just going to push it back onto the bench a little bit. Takes a bit of time to recharge, so we're back up to about 40 psi. Okay, so it's a few days later and I'm having another go at looking into this little project. So last time I was able to get Polaris up and running with the compressor and it was getting some reasonable results. I was only testing it on about 50 psi, but it was still flipping. So it shows that even on very low pressure, the robot could still work. Here's where I've got to now. So I've got the compressor on a little 3D printed mount and the LiPo on a little piece of HDPE. And this is a 3-cell LiPo, 2.2 ampere hour. It's the same one that I normally use to drive Soundwave. So that should have plenty of power to run this little compressor for 3 minutes. The compressor itself, as I said before, isn't the most powerful, but it does need a little bit of regulating, and that's where the pressure switch down here comes in. So this is a little pressure sensor, and when the pressure builds up to 120 psi, it's going to switch the compressor off. When it drops below 90 psi, it's going to restart it. And the idea behind this is I don't want to leave this running throughout a whole battle, because if I don't do any flips, it could get to the point where it ends up burning out the motor or blowing a seal, and then it's going to be no good to me at all. So this is to try and preserve it. Obviously 120 psi is nowhere near what it would normally run at. Polaris normally runs at 800, but for a few tests here, maybe a couple of battles against my students' robots, this should be absolutely fine. What I'm going to do today is get the system soldered up. It's going to be a really basic system, no RC interference, because I want it to be self-contained. So it's going to be a simple battery connector, link, and then the pressure switch in the middle, just to make sure this compressor does what it's meant to. So let's get that going, and we'll get this back in the robot and see if it works. And here we go. This is it all wired up. So we've got the link connector here. The battery's already fitted, as you can see, and we've got the pressure switch wired in down here. Next step, let's fit this back into Polaris and see what we've got. And here we go then. This is Polaris with the covers fitted again. You can see everything fits really nicely under here. If I open the access panel, I can get to the weapon link nice and easily. So that's normally where I'd switch the CO2 on. The main power link's over here. And as a reminder, these are completely isolated systems. So doing it this way around allows this to be potentially moved into any one of my machines. I think we're now at a point where I can give this little test and see if this whole system works. Well, there we have it. I think that was a pretty successful test. The compressor system was able to produce enough power to flip. It could self-right. Did take a little while to recharge though, and the pressure switch never kicked in, so I'm believing that it didn't hit the full 120 psi. But other than that, I think everything is pretty good, and I'm really impressed with how that went. So going forward, I think I do need a more powerful compressor, one that's got a slightly higher flow rate, but also can reach a bit higher in terms of the pressure, so that we can get that pressure switch to start activating and switching off. I think half the issue though is the system in Polaris does have quite a large buffer tank, so that might be limiting it somewhat. But I think overall, as I said, really successful first test. Now I can imagine that some of the questions I'm going to get asked are how can we have a go at building a system of our own using this type of setup. So what I'm going to do now is show you a really basic way that you can have a go at building your own. What we've got here is the most basic type of pneumatic system you can make. So it's got the compressor setup from Polaris that I've just fitted at the back. So that's got the battery, the compressor, the little pressure switch, and then it's got a T-piece that sends it onto this big loop of 8mm thick pneumatic pipe, and then that goes into a 3-2 valve. Now you can pick up one of those from eBay for about anywhere between 12 and 15 pounds, and then the ram is a little single acting ram, same idea, got it from eBay for a couple of quid. What would happen here then? You would charge up the system using the compressor, and the pipe would act as a buffer tank, so it gets away with that need for a proper tank. The valve, when it activates, allows a burst of gas through to the ram to raise it, and then when you switch off the power, which you connect just to those two, so that basically goes onto a battery or a switch, when you take away the power, you can then vent the ram and that will return under gravity. Now there is one thing missing from this system, and that is a dump valve, because I haven't actually got a fitting that would work with this at the moment. So all this does is it plumbs in off of a T-piece, something like that, and then you can open and close that valve to vent all of the additional gas at the end of a fight. This system isn't very expensive, so if you're going to add all of that up, the compressor is about £11, got that from Amazon on Prime. The pressure switch was also about £3.99. You've then got about 15 quid for a valve if you're going for a top end one. This ram I got off eBay for a £5. You can find loads of them on there for really cheap prices. So I reckon if you had to buy all of this, including the fittings, you'd probably be looking at no more than about £40 to £50 all in all if you're going for proper high-end stuff. And that would get you a suitable setup for a sportsman class robot. It'd be great for the Bristol Bevs tournaments as well, as you could fit this up to a flipper or an axe. And the great thing is it doesn't rely on any CO2. It's all self-contained, and really that's what I was looking for when I came up with this. Well, there we go. That is a nice basic system that you could use if you wanted to get involved with building your own pneumatic featherweight robot. But don't forget, pneumatic systems are incredibly dangerous. So if you're not sure what you're doing, either consult someone who can help you, or please don't try it at home. Now, overall, the whole point of this episode was to see if I could find an alternative to using CO2 for when I'm either testing my robot or doing some battles against my students' featherweights. Hopefully I'll have one of those coming up in a couple of weeks' time. And I think I have been quite successful. The compressor setup has proven that it's able to get a reasonable flip, and it can self-right Polaris. But I still think there are some tweaks to make. A slightly more powerful compressor would be ideal, one that can hopefully get it up to that magic 120 psi to activate the pressure switch. But I'm going to work on that over the next couple of weeks, and hopefully we'll have an update for you later on in the year to see if I've managed to get this working. So if you've enjoyed today's episode, please hit that like button and subscribe to our YouTube channel so that you never miss an episode of our Team Shock Builders Log. Brand new episodes will be available every Saturday at 7 PM. And if you've enjoyed that, please do come and join us next week. So that's all we've got time for this week. Thank you very much for watching, and hopefully see you next time. Bye-bye.